Today we're going to talk about inverses and contrapositives of a conditional statement. Okay. Do you guys remember when we had a conditional statement, right? We learned something about converse of a conditional statement. You guys remember that?
Yes.
Yeah. So these are going to be similar to that. So first of all, who wants to read this for us? How about Naomi? Go ahead.
You have already studied the converse of an if-then statement. Now we consider two other related conditionals called the inverse and the contrapositive.
Correct. Inverse and contrapositive. So let's say that if I have this conditional statement, if P then Q. By the way, what did P stand for? You guys remember?
3.
Raise your hand.
X.
Yes. How about Chris? Hypothesis. What about Q? Very good. Yes.
Oh wait. Conclusion.
Conclusion is correct. So if P then Q, P stands for the hypothesis, Q stands for the conclusion. By the way, let's see if you remember, what was the converse for this one? Yes. If Q then P. And does it necessarily come out true if the statement is true? No, it depends. It depends, right? So is this inverse. Okay, inverse for this is you basically put not in front of the hypothesis and the conclusion. Anybody guess what that might be then? Jonathan?
If not P, then not.
You got it. If not P, then not Q. So just like the converse, so write that down. The inverse doesn't have to come out to be true if the statement is true. It depends. Okay, it depends on the statement. It could be true or false. Okay. That's the inverse of the statement. Okay, now we're gonna then learn something called contrapositive of the statement. Unlike inverse, where inverse could be positive or could be true or false depending on the statement, right? You don't know. Actually, contrapositive, you could actually contrapositive is a little bit different. First of all, the contrapositive is the converse of this inverse. So who could tell me what the contrapositive of this statement might be? It's the converse of this inverse. That's what a contrapositive is. Michael?
If not Q, then not P.
Correct. It's if not P, then not Q. And turns out, unlike inverse, contrapositive and the statement.
All is true.
Yeah, if contrapositive is, if the statement is true, guess what? Contrapositive is also true. If statement is false, contrapositive is also false. Those are equivalent. Logically equivalent. We call it logically equivalent. So it turns out statement and the contrapositive are logically equivalent. Okay. In other words, they're saying the same thing.
Inverse and contrapositive.
No. Statement and the contrapositive. Statement and contrapositive, right? These two statements are logically equivalent, meaning they're saying the same thing. Okay, if you do this. Does that make sense? We'll do an example and see if it makes sense. Okay. May I move on? Okay. People still writing? Okay, I'll wait. So let's do an example. You don't have to write this down, but let's just take a look at it. Write A, the inverse of inverse, and B, the contrapositive of the true conditional. Here's the true conditional. If two lines are not coplanar, then they do not intersect. Which two lines are we talking about? We're talking about these two lines are they parallel? No, these are the so if two lines skew, these are skew lines. That's what we're talking about. If two lines are not coplanar, then they do not intersect, right? So can somebody give me an inverse for this? The inverse for this statement. And look what we just said. Inverse is putting. You don't have to write this one. Who could tell me? How about Yvetta? Can you give me the inverse of the statement? Hmm? That's the inverse? Inverse is so what does that mean when you say not twice? If two lines are what? Coplanar, then they intersect. Is exactly right. Okay, there's inverse. And that's false, right? They don't have to intersect, do they? They could be parallel. What about then, who could give me the contrapositive for this one here? Who have not called? I haven't called. Tony.
If two lines intersect, they are coplanar.
If two lines intersect, then
It's true.
they are coplanar. And this is true, correct? You see how the true statement, we had a true statement. When you take a contrapositive as true statement, still true. Okay. All right. So as you can see, the inverse isn't that way, right? Inverse, if the statement is true, it doesn't guarantee that inverse will be true. But turns out, if the statement is true, the contrapositive will be true. If the statement was false, guess what? The contrapositive will be false. Does that make sense? Question?
Yeah, so where's like the not part?
It cancels out.
Yeah, so not means. Okay, so let's move on. Sir, can you read this for us? Here we go. You can use.
You can use a Venn diagram to represent a group. So
Mhm.
any point inside circle P is also inside circle Q. This diagram represents.
Yes. So as you can see, the P is inside of Q, right? So what does this diagram represent in terms of a conditional? If something, then what? One person see it?
Wait, what?
As a conditional using P and Q, right? What would this? Would it be if P then Q, or would it be if Q then P? You don't think it does matter big time? Okay, go ahead. Discuss with the group. What do you think? What does this Venn diagram represent? So, how many people think? Actually, I said I was gonna call somebody random. How about Brandon? What did you guys come up with as a group? What did you guys decide?
Q then P.
If Q then P. Okay, raise your hand if you said if Q then P. Okay, some of you. Okay, not all of you. So let me ask you this, Brandon. If Q then P, if you said that, then that means if I'm in Q, does that mean I'm in P also? 'Cause that's what you're telling me. If you're saying if Q then P. Do you want to change your answer? Because if you said if Q, listen, guys, if you said if Q then P, then you're telling me if you're in Q, that means the conclusion has to be that you're in P. Is that necessarily true? So guess what, Brandon? It's gotta be if P then Q. Then is that true? If you're in P, are you guaranteed to be in Q? So this diagram represents if P then Q. Okay? So right now, I would like you to, guys, I would like you to draw the diagram on your note and write down, Jason, that this diagram represents if P then Q, right underneath the diagram. Okay, so this represents if P then Q. Brandon, does that make sense?
Yeah.
Okay, do you see why it's not the other way around? Because that would be wrong. So this diagram, Venn diagram, represents if P then Q. Jason, question?
What about the contrapositive?
We'll get there in a minute. Very good. So write that down first, okay? Okay. Anybody need more time? Now, let me ask you this. What would this diagram also represent? So, yeah, contrapositive for this. So does it make sense? What would the contrapositive of this be? If what? If not, is it if not P? If not Q, then what? In other words,
That's true.
yeah. So who would like to read this similarly part? Go ahead, Kevin. I'm sorry, here we go.
Similarly, if a point is not inside circle Q, then it can't be inside circle P. Therefore, the same diagram also represents.
Who could tell me? Which is Grace.
Not Q then not P.
Correct. Does that make sense? Do you see how if it's not in Q, right? That means it's going to be outside of this big circle, right? Then of course it's not going to be in P. That's obvious. Does that make sense? So the statement and the contrapositive represents the same picture. Now, guess what? They are called logically equivalent. Because Nicole, can you read this part? Since the same diagram.
The same diagram represents both the conditional and its contrapositive. These statements are either both true or both false. They are all logically equivalent statements.
Does this make sense? Okay, it represents both. If P then Q, and if not Q and not P, represents this picture, this Venn diagram. Any question? Yes, sir.
So if it represents both of it, it's called logically equivalent.
No. So what we're just basically saying is the statement, the conditional, and the contrapositive are logically equivalent statements. It represents the same picture here. Does that make sense? Okay, it's saying the same thing. It's a little bit different. but the end result is the same. It's representing the same picture. Okay. All right. So then let me change the picture a little bit so that the Q is inside now and P is outside. So then what would this be? If what? If P then really? Okay, if Q then P, right? If you're in Q, you're guaranteed to be in P, not the other way around, right? So, and when we say that, what is that in terms of the statement? If P then Q. This is the inverse? Is this the what? Actually, before we get there, let's read this statement. This is really important. Since the conditional, the reason why we're doing all this, okay, can somebody read this for us? Since a conditional statement, how about somebody has, Brianna, go ahead.
Since a conditional and its contrapositive are logically equivalent, you may prove a conditional by proving its contrapositive. Sometimes this is easier, as you will see in exercises 21.
What are they saying here, guys? This is the reason why we're studying this contrapositive and the statements and so forth. Why are we doing this? Because, Jason? Sometimes it's easier to prove proofs using contrapositive of the statement. Does that make sense? So if they ask you to prove something, if hypothesis then conclusion, right, you could use the contrapositive to prove that statement. It'll still be true. Does that make sense? So it's easier to prove, right, as a contrapositive than actual statement that they gave you for you to prove. Does that make sense? And so let's go back to this picture. This picture represents if Q then P, right? Therefore, this is the what? Converse, right? So if P then Q. Then what do you think? Is there another way to represent this picture other than saying if Q then P?
Yes.
Go ahead, discuss. There is a way. What do you guys think of it? All right, so how many people, okay, first of all, do we all agree that this picture represents if Q then P, correct?
Yes.
So what does it represent? How many people say if not Q then not P? Raise your hand. Oh, no, none of you. So what does it represent? Yechan. If not P then not Q is correct. And guess what? That's the inverse, right? Isn't that correct? So what is it saying here? If Q then P is the converse, and not P then not Q is the inverse of the statement, what can you conclude? What can you say? Yes?
The converse and inverse statements are logically equivalent.
Exactly right. Very good. Therefore, the converse and the inverse of the conditional statement are also logically equivalent. Do you agree? It represents the same picture, doesn't it? Yes?
That's not always, right? Just this.
No, this is always.
Oh, always.
Yeah, so always, so here's a summary. This is always true. Summary of what we just talked about. If you have a given statement P then Q, guess what? The contrapositive of this statement is logically equivalent. Okay? If you have a converse, if Q then P, then guess what? Inverse is also logically equivalent. Does that make sense? So write this down, guys. I'll wait for you. No, we're saying the first two statements are logically equivalent. The last two statements are logically equivalent.
So the inverse is equivalent to the converse.
Yeah, or converse is, yeah. Of the statement if P then Q, right? Yes?
Isn't basically saying the same thing?
Exactly, it's basically saying the same thing. They're just now replacing P and Q. You're right. We'll do an example, see if it makes sense, okay? And one of the points was we just talked about it. When we do proofs, right? We want, if the statement is given, then we could actually prove the contrapositive of that statement. And it will be the same thing.
To use this in proofs?
As we said, one of the things that we could use this contrapositive is, right? When you do proof, sometimes it's easier to prove it's contrapositive than the actual statement. So that's why we're learning it, okay? So, and that's why we're trying to understand why they're logically equivalent. Okay. Let's do some exercise then using these. Okay, so who would like to read this for us? Go ahead, Jason.
Using a Venn diagram to illustrate conditional statements and also help to determine whether an argument leads to a valid conclusion.
Okay, so we could actually use the Venn diagram to help us whether or not it leads us to a correct conclusion. So let's say that this conditional statement is true. All runners are athletes. What would this be as a conditional statement, by the way? If a person is a no. Thank you. If a person is a runner, then the person is an athlete, right? That's what it would be if, as a conditional. So let's say this is true, okay? So knowing this, I'm going to give you some additional statement and see if you could figure out whether that statement leads to a conclusion, to a. So hold on, let me. So if let's say that we have this statement, all runners are athletes, and I told you that Leroy is a runner. What can you conclude from this additional statement? Okay. How about Dylan? He's an athlete. How many people agree with Dylan? Anybody have a different answer? Because he is correct, okay? Right? He is an athlete, right? Because, and we just said the Venn diagram would help us. Here's the Venn diagram. By the way, what would be in the inner circle? Runner inside, and then what? Athletes at the pickle. You're exactly right. And where would the Leroy be? Inside the runner. Therefore, if Leroy is a runner, right, we could conclude that Leroy is an athlete. Is this easy? Okay, let's move on to the next one then. Find out. Here we go. All runners are athletes. Again, same statement. Lucia is not an athlete. Okay, everybody go ahead, discuss with your group. What do you guys think? How about, let me ask, Esther, what do you think? You, over here. She is not a runner. How many people agree with her? Okay, so this is the picture we have. And since Lucia is not an athlete, yes, we could conclude that she's not a runner, right? Because it's outside of the circle. Does that make sense? Outside of the Venn diagram. You guys understand what we're trying to say? All right, let's move on to the next one then. All right, everybody think about this one. All runners are athletes. Again, the same statement, so we have the same Venn diagram. And it says Linda is an athlete. What do you guys think? Go ahead, discuss with the group. What can you conclude? Amy, what did your group come up with? Can be, so may or may not be, right? We don't know because, look, here's the picture, right? It says Linda is an athlete, so Linda could be in here as a runner, or it could be outside of the circle of the runners, right? So you don't know, so you're right. So she might be a runner or she may not be. We don't know. This conclusion isn't, right? We can't really draw a conclusion for that. Does that make sense? Yeah, or maybe, yeah. So, which means that, right? Okay, let's move on. This example, again, same Venn diagram because it's the same statement. All runners are athletes. What about Larry is not a runner? Go ahead, discuss. What do you guys think? Iveta, what would you say? Yeah, may or may not be an athlete because here's the picture, right? It says Larry's not a runner, so Larry could be inside the athlete or outside of the athlete circle. Would you not agree? Okay, do you see how that works out? Okay, any questions? Let's do a couple more examples, and I want you to write this one down. Okay, hold on. Here we go. So it says write A, inverse, and B, the contrapositive of each conditional statement. Sort of similar to before. So example 1, if a parallelogram is a square, then it is a rectangle. Can you guys write down the inverse and the contrapositive? That's all you need to do. Write down the inverse and the contrapositive for this. Go ahead. I'll wait. Okay, Eamon, can you give me the inverse of this statement? If the parallelogram, what? Is not a square, then what? It is not a rectangle. Very good. Can somebody give me, how about, Eric, can you give me the contrapositive for this? Yeah, if a parallelogram is not a rectangle, then it is not a square. Any questions? You don't need to write down true false.
I know, wait, but...
Example 3. If 2x plus 1 is greater than 15, then x is greater than 7. Who could give me the inverse for this here? Remember, all you have to do is, for hypothesis and conclusion, you just have to put not, right? For this. But in this case, how would that be? I put a star on this one. Okay, so... Okay, Kevin, what do you think?
If 2x plus 1 isn't greater...
Right, so isn't greater than 15, which means not greater than 15. Yeah. What would that be? How many people say it's less than 15? Raise your hand. Okay, that's how you get it wrong. It's not going to be less than 15. Opposite of greater than or not greater than is not less than. What would it be? Jason?
Less than
Eamon, what do you think? Less than or? How many people say less than or equal to? You guys are correct. Okay. So opposite of greater than is less than or equal to. Why? Go ahead. I want you to discuss. Why is this true? Okay, so who could explain why opposite of greater than is less than or equal to? Who could explain? Eamon?
Because it could be equal to, because equal is not the same thing, it's the opposite of.
Right, exactly. When you say it's greater than, right, you don't include equal to, does it? So therefore, whatever that's not greater than, it's got to be less than or equal to. Now, lastly, what is the contrapositive for this? How about Kristen? Correct. Does that make sense? Okay, do you see it? Do you guys understand? Okay, opposite of greater than is what? Less than or equal to. Any question? Does this make sense?
Yes.
All right, good.